this video, we're going to take a deep dive into simplifying rational expressions. We're especially going to look at extending things to adding and subtracting rational expressions. So first of all, what we have to recognize is we're going to have to find least common denominators when we're adding these fractions. You have to have a common denominator to add or subtract. And when we refer to least common denominator, we can also refer to that as the least common multiple. So when we refer to either one of those, they're the same thing. When we're looking at fractions, it's least common denominator. When we're just looking at polynomials, it's going to be least common multiple. So first of all, we're going to be looking for every factor with the greatest exponent. Now just a note that this is going to be counterintuitive at times, because we're looking for the greatest exponent when we're looking for the least common multiple, least common denominator. And the reason why it's the greatest exponent is because we're looking for something that it has in common. So the greatest exponent helps us establish the common multiple, not the least. The least is going to be a part of how we do this, how we take the factors. So let's go ahead and now look at these in factored form. If we look at the prime factors, 2 times 3 times x squared times y, and 15 is 3 times 5 times x to the 4th. For the least common multiple, you're going to take every single one of these factor bases. 2, we take 3, we took the 3, so we don't take it again, but then we take the 5, and we're going to take an x base and a y base. Now, when you look at these, you're going to then look at the exponents. And if there's more than one exponent listed, you're going to take the greatest one. On the 2, the 3, and the 5, they're all an exponent of 1, so we just leave those alone. But for the x, notice that this is x squared and this is x to the 4th. X to the 4th is the larger of the two, so we're going to make this to the 4th power for the least common multiple. The y, there's just a y to the 1st, we just leave that one alone. So when we multiply this out, 2 times 3 times 5 gives us 30, x to the 4th, and then y for our least common multiple. Now, the next part that we're going to do is we're going to look at it when we've got these two trinomials. We want to factor them first to find out what our factors are. So we're going to take out a 2 out of this first, x squared plus 2x plus 1. And now I'm going to factor this into 2 binomials, and it's going to be x plus 1, x plus 1. Now when we have the same factor listed twice, we're going to list it in exponent form. That's x plus 1 to the 2nd power, because there's 2 factors of it. Now we go over here and factor this one. This can be x plus 4 and x plus 1, how this trinomial factors. So for my least common multiple, take every factor. I'm going to take the 2, I'm going to take an x plus 1, and I'm going to take that x plus 4. I already took the x plus 1, so I don't take it again. And now this x plus 1 has a 2 on it, this x plus 1 has a 1 on it. Take the greatest exponent. So I'm going to take it as a factor that I have a square on it for my least common multiple. So that's my least common multiple for those 2 trinomials. All right, now let's go ahead and get some ideas in order to do it with fractions. So we have to remember that when we have fractions that are added or subtracted, we have to have a common denominator. They require a common denominator. Okay, so when we look at these don't have common denominators. We're going to have to establish a common denominator first. What the technique we'll use is we're going to multiply each fraction by what its denominator is missing. All right, so let's look at these two. We're going to do it with rational numbers first, just to tie back to the problems that you've done in your past. Probably in earlier math classes, you've done it with just rational numbers without variables. Let's start with these. What we would ask the question is, for the common denominator, the least common denominator, what's the smallest number that 8 and 10 go into? Now you probably be able to figure that out, but if we go ahead and just follow our rules here for how we're going to do this. What we talked about, I'm going to use this rule here. We take every factor with the greatest exponent to do this for our least common denominator. So for this, I have 2 to the third, and this is 2 times 5. So my least common denominator, I'm going to take the 2, and I'm going to take the 5, and then I compare the exponents on the 2. 3 compared to 1, I take the largest exponent, that's a 2 cubed. 2 cubed is equal to 8. 8 times 5 is equal to 40. So the least common denominator for this is a 40. Now, we're going to look at each of these fractions, 1/8, and we're going to multiply by what it's missing, and the 1/10, and multiply it by what it's missing, top and bottom. Well, this 8 has a 2 cubed. I need the 5. So you multiply by 5 over 5. This 10 has a 2 times 5. It's got the 5, it has 1 2. I need to have 3 factors of 2, so it's missing 2 factors of 2. 2 squared is equal to 4. So I'm going to multiply it by 4 over 4. So this becomes 5 over 40 plus 4 over 40. Now once you have the common denominator, you can go ahead and write them over the same denominator. Make sure you do not change the denominator. The denominator we got in common. When we add fractions, we add the numerators, the denominator stays that common denominator. 5 plus 4 is equal to 9 over 40 for my answer for this one. All right, let's go ahead and do it with this one. We're going to again look for the least common denominator. This is a 3. This is a 3 times 4, which is a 3 times 2 squared. So when I take my least common denominator, I'm going to take the 3. I already took the 3, so I don't take it again. I'm going to take the 2, and I'm going to take the greatest exponent, which is a square. 3 times 2 squared is just equal to 12. You probably figured that out ahead of time, that since 3 goes into 12, the least common denominator is 12. But this kind of shows how the rule works with numbers, and it will help when we look down here with variables. All right, so 1/3 times what it's missing minus 5/12 times what it's missing. 1/3 is missing the 2 squared, which is a 4, so I need to multiply it by 4 over 4. Remember, by multiplying by 4 over 4, 4 over 4 is equal to 1. So by multiplying by that, I'm not changing its value. I'm just changing its form, so it now is a common denominator. But in a fraction, that is the same value. This 12 is not missing anything, so you don't have to write this, but think of it as multiplying by 1 over 1, because it has the common denominator already. So this will be 4/12. 4/12 is the same as 1/3, just in a different form. Minus 5/12. Now don't reduce this one, because we did all that work to get the common denominator. So we're going to leave it with the common denominator and put the 4 minus 5 over the 12. That gives me -1 over 12 for an answer for that. So now we saw how it works with rational numbers. Let's do it with rational expressions, with variables involved. Our 3 steps will be, we're going to create an LCD, we're going to combine the fractions, and we're going to simplify. So we will use, one of the ideas we'll do is, we'll go ahead and look for what's missing from our LCD just from before. So this, 2x cubed, 8 is 2 cubed. So I take every factor, I'm going to take 2, I'm going to take an x, and I'm going to take a y. Now look at the exponents, 2 to the first, 2 cubed. I'll take the 3rd power, the largest exponent. X cubed, x to the first, compare 3 and 1, I'll take the 3rd power. And then this y squared, I need to take that exponent. So this will be 8x cubed y squared for my common denominator. Now I'm going to take this 3y over 2x cubed, and I'm gonna multiply by what it's missing, and add to it the 5 over 8xy squared times what it's missing. This has the 2, it needs an 8, so it needs 2 more factors of 2. It needs 3 total, it has 1, so I gotta multiply it by 4 over 4 in order to get that 8. It's got x cubed, so I don't have to change that one, but it doesn't have the y squared, so I need to multiply by what it's missing in the numerator and denominator. There, 4y squared over 4y squared is equal to 1. Doesn't change the value, but it's going to change the form. Go ahead and on this one, we have the 8, we have 1x, we need 3 x's, so I'm going to multiply by x squared over x squared, 2 more factors. I've got the y squared, so I don't have to multiply that. Multiply the numerators, leave the denominator alone. So, well, we're going to multiply these 2 denominators here, but we're going to add it to the other common denominator. So we have our common denominator here of 8x cubed y squared, so we accomplished that common denominator. On the top we'll have 12y to the third. Here I'm going to have 5x squared on the top. Multiply the denominators here, I get 5x cubed y squared. So now I've got the common denominator. When I add them, I'm going to list it over that common denominator, 8x cubed y squared, and that's going to be my 12y cubed plus 5x squared for my final answer. Nothing here factors. I can't factor out a common factor to reduce. So you do look to see if there's something that they have in common that you might be able to factor out and reduce with the denominator, but there is none. All right, let's go to this last one on this page down here. Here we're going to go for our denominators. 27 is 3 cubed. So I'm going to take the 3, I'm going to take the x, and I'm going to take the y. The largest exponents on the 3 is a 3. On the x's is a square. And the largest ones on the y's is a 5. So 27 x squared y to the 5th is my least common denominator. Now I take this first one, and what is it missing? In order to complete it to have a common denominator, and the 10 over 27 xy to the 5th, what is it missing? Well, this one has a 3, I need a 27, I need a 3 cubed. So I need a 3 squared or a 9 to complete it. I've got the x squared, I have 1 factor of y, I need 5 factors of y, so I need 4 more factors of y here for this term. Let's do this one now. I've got the 27, I've got an x, I need 1 more x there, so I'm going to make this x an x, and I've got the y to the 5th, so I don't need any more. Now here's maybe a little bit of a shortcut here. Now that I've established my common denominator in both of these terms, I can go ahead and make it one fraction, not having to do it here and then, like to this step and then to that step. Let's put it all over 27 x squared y to the 5th. My common denominator, because I've established it both here, and I'm going to multiply these two together. I get 72 y to the 4th, and here I'm going to have a 10x. So saving it one step here by combining those. Now I can factor out a 2 out of these two, and if I did, if there was a 2 down here that I could reduce with, there isn't, so we've got to make sure that you think about that, but since there's nothing to reduce with it, we've got it in its final form, and we can leave that as our answer. So let's go to the second page where we're going to do these now with polynomials that are larger than a monomial, binomials and trinomials. What you want to do is think of these as entire terms. So I'm going to think of this x plus 9 as an entire term, not the x and the 9 separate because they're being added. They're not factors. But the x plus 3 itself is a factor. The x minus 3 is a factor. So my least common denominator will be this binomial times this binomial. List each of the factors to the largest exponent. Both of them have an exponent of 1. So now each of these fractions are missing the other denominator. So I'm going to multiply this by x minus 3 over x minus 3. Okay, and I'll put them in parentheses just so I see how I'm going to multiply them. Minus the second fraction. And what is it missing? It's missing the x plus 9. So multiply by it in top and bottom to get that common denominator. So here's a hint. Leave the denominators alone so that you make sure that they're in factored form, because later we might be able to reduce. So x plus 9 times x minus 3. Up here I'm going to distribute through the 5. I get 5x minus 15 for this numerator, minus, let's go ahead and distribute through in the numerator here, 12x. 12 times 9 is 108. All over my denominator, which is x minus 3, x plus 9. Now they're in a different order, that's okay. They're still the same denominator, so we can leave them in that order. Now we're going to go ahead and combine them into one fraction, x minus 3 times x plus 9. And up here I'm going to have 5x minus 15. Now watch this, make sure you distribute through the negative to both. This fraction bar is a grouping symbol, so the whole thing's grouped. Make it minus 12x and then minus 108. So make sure that negative makes it all the way to the second term in it. Now I'm going to take these and combine them. 5x minus 12x is negative 7x. Negative 15 minus 108 is negative 123. All over in factored form, x minus 3, x plus 9. Now I left it in factored form because I wanted to make sure that if I find a common factor that can be reduced in it, I'm going to do it. So is there anything I can factor out of that numerator to possibly cancel or reduce with one of these? There isn't, so now I'm going to take the final step of multiplying through the denominator, simplifying. So x times x is x squared, plus 9x minus 3x is plus 6x, and then minus 3 times 9 is negative 27. So this would be my final answer for this problem. All right, so next let's do this one. And this one we're going to find out that it is going to have something at the end that will end up reducing. So it will show why you have to go all the way to the end of looking for things that simplify. So this the second denominator is going to be x minus 2, x minus 1. So I look for my LCD, I take the x minus 1. I already took x minus 1, so I take this x minus 2. So this second denominator is already has the LCD, but the first one's missing something. So we're going to multiply by what it's missing. It's missing the x minus 2. So I'll multiply by x minus 2 over x minus 2. Second one, we just are going to leave alone because it's got the common denominator of x minus 2, x minus 1. Now let's go ahead and multiply these two. We're going to have x squared minus 2x. Now remember that hint of maybe doing something a little early in order to, since they have the common denominator, I'm going to put them both over that common denominator. And notice the denominator does not change when I'm adding or subtracting fractions. You leave it as the least common denominator. You don't change the denominator, but we combine the numerators. So this is going to be plus 2x and then minus 1. So this numerator plus that numerator. Notice that the 2x's, negative 2x and plus 2x will reduce out. So you get x squared minus 1 times x minus 1, x minus 2. Now this factors. It factors into x minus 1, x plus 1 over that x minus 1, x minus 2. Notice that these x minus 1s will reduce out. They're the same factor. So I can simplify by taking those factors out, and I end up with a final answer of x plus 1 over x minus 2. So make sure you do that last step of reducing. All right, let's look at this last one here, number 3. I'm going to be looking for my common denominator here. My common denominator for this one, I'm gonna first of all factor this into x plus 4, x plus 2. And so when I get my common denominator, it's gonna be x plus 4 times x plus 2. And now what I'm gonna look at here is that this first one's missing a factor. So x plus 4 times, I'm gonna multiply it by x plus 2 over x plus 2. That's what it's missing from my common denominator. The second one I can leave as is because there's nothing missing. All right, now I'm gonna multiply through, so I get 10x plus 20. All over, I'm gonna have a common denominator here, so I'm gonna put plus 7x minus 3. Common denominator is x plus 4, x plus 2. Now I go ahead and combine. 10x plus 7x is 17x. 20 minus 3 is plus 17. I do have a GCF I can take out of that. So you have to think it through. If I take out this greatest common factor here of 17, I have an x plus 1 left. That's not a factor down here that will reduce. So I don't have to worry about it, only look for ones that will simplify. Since it doesn't, I'm gonna multiply out that denominator. I get 17x plus 17 on the numerator. In the bottom I get x squared plus 2x plus 4x is plus 6x. And then plus 8. It's that original denominator we had in the second fraction. We multiply it back out. So that's our answer. So now when we add and subtract fractions, the rational expressions, you have to make sure you get a common denominator. Find the least common denominator, because if you don't, if you just use both denominators multiplied by the other fractions, you might get very complicated fractions at the end that need to be factored and reduced, and the factoring of it might be very complicated. So in order to save time in the reducing at the end, you want to get the least common denominator, find out what it's missing, multiply by it top and bottom, combine the fractions over that least common denominator, simplify, and you get your answer to the rational expression.